As we continue our discussion on financial management, we now look at the concept of diversification and try and use it in a portfolio of two stocks and try and understand what is the impact of having a couple of stocks with different correlations, in the portfolio, and try and see what happens to the portfolio variance and what is the learning from that entire discussion that we have, right? For the purpose of this discussion, we're going to assume that there are two stocks in the portfolio, and these two stocks have different proportions, and what is going to happen at the variance at different weightages. That's what we're going to look at. Let's assume stock one has a monthly return of 1.75% and a standard deviation of 9.73%. Let's say stock 2 had an average return of 1.08 and a standard deviation of 6.23. Correlation is 0.37. How will the portfolio of these two stocks perform, right? Now, we know that expected return of the portfolio is nothing but weight of stock 1 into return of stock 1 plus weight of stock 2 into return of stock 2. So that's straightforward. We can calculate that, whatever weights we use, right? Now, variance of the portfolio, sigma p square, is given by weight of 1 square, sigma of 1 square, plus weight of 2 square, sigma of 2 square, plus 2 into weight of 1, weight of 2, sigma of 1, sigma of 2, and correlation between 1 and 2, right? So we have all the values with us. We can try and calculate this and try and understand what happens to this portfolio. So for the calculation purposes, we're going to use various weights where weight of 1 is going to vary from 0, 25%, 50%, 75%, and 100%. And obviously weight of the second stock will then become 100%, 75%, 50%, 25%, and 0% in the portfolio. So we're going to look at these combinations and try and identify what is going to be the portfolio variance and what is going to be the portfolio returns, right? So let's go to an Excel file. So that's our Excel file that has the data available with us, and the data is stock 1 return, stock 1 standard deviation, stock 2 return, stock 2 standard deviation, and correlation coefficient. Weightages are given to us. Can we calculate the portfolio variance, portfolio standard deviation, and portfolio return, right? Let's first calculate the variance. That's going to be standard deviation squared. So that's my variance number, 0.95 square, and I'm going to find the variance for the other one, which is 0.39 square. So variance for stock 1 and variance for stock 2 has been calculated. What have we done? We have just taken the standard deviation, whatever is the standard deviation, and we have squared it, right? Now remember the formula. Formula is weight of 1 square sigma square, right? Then to this we add weight of 2 square sigma 2 square. Remember, these are variances, so plus, and then we add 2 into weight of 1, weight of 2, sigma of 1, sigma of 2, rho 1, 2. That's the formula, right? Let's try and calculate that. So our term, I'll put a bracket, and let's probably increase the font size a little bit. So this would be weight of 1 into weight of 1, that's weight of 1 square, multiplied by sigma of 1 square, that's the variance of stock 1, correct? And that variance of stock 1 will always remain constant, so I'll freeze this by adding dollar signs, then do plus weight of 2 into weight of 2 into sigma of 2 square, and we freeze that as well. So that takes care of the first two terms, right? And now we look at the third one, that is in a bracket 2 multiplied by weight of 1 multiplied by weight of 2 multiplied by sigma of 1, freeze this, multiply by sigma of 2, freeze this, and multiply by, sorry, sigma of 2 is actually given here, B7, freeze this, and multiply with the correlation coefficient and freeze this, right? Why have I frozen only the standard deviations and variances and correlation? Is because when we drag it down, we would want the portfolio weightages to change, but we don't want the other values to change, right? So that's the formula. Let's look at this carefully and closely. We have weight of 1 square, that's A11 into A11, that's here. Then sigma of 1 square, that's the variance of stock 1. Then we have weight of 2 square, that is B11 into B11, multiplied by sigma of 2 square, that's variance D7 for stock 2, plus 2 multiplied by weight of A into weight of B into sigma of 1, which is now the standard deviation, sigma of 2, which is the standard deviation of the second stock, and correlation between these two. So that's the term that comes here, right? So that's our calculation, and we can press enter. We get portfolio variance as 0.39%, right? That's the portfolio variance. Can I control this, copy this, and paste it as formulae? Okay, that gives me the portfolio variance at different levels of portfolio weights, correct? That's the portfolio variance at different level of portfolio weights. If I calculate the square root of this, that's going to give me the standard deviation. And if I calculate the portfolio return, that's going to be 0% multiplied by stock 1 return, freeze that, plus 100% multiplied by stock 2 return, that's this, freeze that, enter. I can copy these, I can drag this down, and I can select this, Control C, and paste it as formulae. Select all this, paste it as formulae. Right, so that gives us the values that we were looking for. Just going to reduce the decimal points here. We can erase the drawings, and now when we look at this in detail, what is it that that we see here? We find that based on different weightages of the stock, we have been able to calculate the variances of the portfolio. Taking the square root of the variances, we have arrived at the standard deviations of the portfolio, and subsequently we have also calculated the portfolio return, right? So you see, portfolio return keeps increasing, but the same is not true for variance. Variance actually goes down, then goes up again, right? So from 6.23%, when you have 100% of stock 2 in the portfolio, the portfolio variance is going to be the same as the portfolio standard deviation is going to be the same as stock 2 standard deviation. When you have 100% of stock 1, then the portfolio standard deviation is going to be the same as standard deviation of portfolio of stock 1. At varied combinations, depending on what the correlation coefficient is, we're going to find various standard deviations, right? Now let's see this in more detail. What we have here is that we find that as we increase the weightage of stock 1, at some point the portfolio variance goes down and then it again starts going up, right? So there must be a particular weightage of the two stocks where we are minimizing the risk, right? Let's actually plot these two on a curve. So we're going to select this data. We're going to insert a chart, and in the chart we're going to use a specific kind of chart which is called as XY scatter. We're going to use XY scatter. So when you select XY scatter, we could select any of these points, and let's select the third one here, and I'm going to select this portfolio return chart. I'm going to click OK, and this is what we find. Now when you look at this, on the x-axis you have the standard deviations plotted. On the y-axis you have the returns plotted. So as you keep changing the weightages, there is one point here. There is some point here where you're going to minimize the risk in the portfolio, right? There is one point here where you're going to minimize the risk of the portfolio, and that's possibly going to be the point where you have the best risk adjusted return for the portfolio, right? Now we'll get into more details about this as we go along, but that's how you basically make a plot. I'll just move this downwards because we're going to do some interesting changes to the data and look at data as it goes along. So that's the data we had. That's what we find. What happens to the portfolio weightages? What happens to the portfolio variance based on that? And the minimum variance portfolio here is this one, which is 25% weightage to stock 1 and 75% weightage to stock 2 gives me the minimum value for portfolio standard deviation. That's the minimum risk portfolio that we have created, assuming a correlation coefficient of 0.37. That's what we just plotted. So this point here is where we have identified the minimum amount of variance or risk, in other words, right? That's the combination that we were looking for, right? Now what do we do? Let's change the correlations. What happens if the two stocks did not have a correlation coefficient of 0.37, but we change it for values between -1 and +1, right? So let's try and change it for values between -1 and +1. So let's look at what happens when we put this as 0, right? Note very carefully, once I change this to 0, the returns are not going to change because the return does not really look at the formula using correlation anywhere. But variances and standard deviations are going to change. Even within that, remember the beginning point and the end point are not going to change. The moment you have one of the stocks at the weight 0, you note 6.23 here and 9.73. I will press enter with this at 0, and you note that once again the values at the extreme points do not change. Why is that so? Because if W1 or W2 is equals to 0, right? Then the entire term 2W1, W2, sigma 1, sigma 2, rho of 1 and 2 becomes 0. Right? So practically, the only thing that is left is W1 square sigma 1 square in one case and W2 square sigma 2 square in the other case, right? So whatever I do with the correlation, we will note that the extreme values don't change, but the intermediate values have now changed. Earlier, we did not see a value anything below 6%. Now we see 5.27. If I actually just put it as 1, right, which is basically two stocks having same correlation, there's the same movement, then whether I use one stock in the portfolio or I use two stocks in the portfolio, this is going to become a linear movement. It'll keep increasing in a straight line, right? Whether I have one stock, as I keep increasing the weightage of the other stock, it's like both stocks are the same, so it never goes down, right? If I change this to -1, however, if I change this to -1, we realize that if portfolio stocks are completely negatively correlated, one moves in the opposite direction to the other, you find that the minimum risk now moves to 1.75%. The return does not change, but the risk keeps going down as the correlation coefficient keeps going down, right? That's exactly what we wanted to kind of check as to what happens on various correlations that we are looking at. So if the correlation is going to be around 0, then what do we see here? We see that minimum variance is now 5.27% at rho equal to 0. That's what we get. At rho equal to 1, The minimum variance is 6.23, and there is a linear increase in standard deviation of the portfolio, right? It just keeps increasing. So if you were to plot it, it'll probably come as a line like this at rho equal to 1, right? At rho equal to -1, you find the minimum variance portfolio is this one. At rho equal to -1, standard deviation of the portfolio minimum is going to be 1.75%, and that's at these weightages, right? Now let's try and plot all of these together, right? So how do we plot all of these together now? If we plot all of these together, this is the curve that we saw at rho is equals to 1. This one is rho equals to 0.37. This one is rho equals to 0, and this one is rho equals to -1. So rho equal to -1, rho equal to 0, rho equal to 0.37, and rho equals to 1. Those are the four curves that we have created, and you would note that for the same portfolio return, if the two stocks have lower correlations, you keep moving leftwards, you are effectively going to arrive at the least risky portfolio, right? This is also known as the optimal portfolio. Obviously, this depends on what is the correlation between two stocks, but if you have a lower correlation, that would give you a lower risk of the portfolio at the same return calculations. If we just keep reducing the row values, we keep finding that the portfolio, the endpoints, remember, remain the same. We saw that the endpoints, which is assuming that one stock is 100% is stock 1 here and 100% is stock 2 here. The endpoints remain consistent, but intermediate points keep kind of changing. And that's what basically shows us the importance of lower correlation, right? The importance of lower correlation is in terms of a lower risk portfolio. This structure, this structure is essentially what is called as the optimal portfolio, and it has significant far-reaching impact in terms of our entire capital market theory that we're going to study in subsequent sections. So the least risky portfolio is what we were trying to create and understand what is the importance of correlation when we keep changing correlations in our example ranging from -1 to 1. On our Excel file, we kept seeing that the portfolio variances will keep changing, and based on that, we have calculated this plot, right? Now, what are our observations? Return of the portfolio will be a weighted average of the stock that we knew, and that's going to be fixed at a given weightage regardless of what the correlation is. Lower the correlation among stocks and bonds, lower the variation from mean or the standard deviation, or we're going to say lower volatility, right? That's what we have identified. Higher returns can lead to higher variance or variation. One should ideally look for the optimal portfolio. So we saw that if we were trying to increase the returns, that's going to increase the risk as well in all cases. As we try to look for higher returns, in all cases, we were seeing the risk increase outward as well, right? Look at this. As we keep seeking higher returns, we will see risk again kind of going ahead and increasing eventually, right? That's what our first set of observations is. We also look at what is going to be the use of this plotted curve. So when we look at the plotted curve, the first usage is to determine what is the optimal return, right? What is the highest return? What is the lowest return? What is the return in terms of intermediate calculations that we do for weightages? What is the optimal variability, which is least risky portfolio, we can find out what proportions, above 2 will lead to a decision on what proportion of stocks should be a part of the portfolio. I mean, what is the weightage that you're going to kind of decide? That's going to get decided based on point 1 and point 2. So 1 and 2 combined tell you what weights we should have for the stocks, for the stocks. And that is what is the primary objective of understanding what is an optimal portfolio. We will learn that the optimal portfolio is also kind of called as the efficient frontier, and what are the uses of that efficient frontier in subsequent sections. For now, we're going to kind of play around a little bit with that table, and you can use the Excel file for kind of working around with a variety of stock weightages and correlations and return combinations. We will end this video with a particular question, which is, if you have a portfolio of two stocks with weights 60 and 40 and standard deviations of 10 and 12% respectively, correlation is 0.45, you need to try and calculate the variance of the portfolio. And you can try and calculate the variance of the portfolio by changing these weightages as well. So change the weightages and you can try and calculate what is going to be the variance of the portfolio based on that.